So in our today's class, we are going to see the next concept in gravitation. So that is what gravitation potential. That is what potential difference. So what is the gravitational potential difference? That is what we can say like introduction alone. So next coming classes, we are going to derive many things. So gravitational potential, that's what introduction alone, we will see this in our today's class. So go back to the class 10th and you can see we might be studied potential difference or of course electric potential. So electric potential. So let me tell you remember I have taught you people. So electric potential means we are having somewhere a point A, so for example. So we are having some unit coulomb, that is what unit of charge at infinity distance. So to bring this q amount of charge from infinity to the point A, so we need to do some work done. Am I right, everybody? Please respond, all of you. Yes or no? So now the work done to bring the q amount of charge from infinity to point A, that is what work done per q amount of charge. That is what we used to call it as a electric potential, which will also represented with the volt. Am I right, everyone? Yes or no, Rudresha?
Yes,
So now potential difference also we used to say, this is class 10th one, same thing. Voltage means, so there is a two inside the electric field. So there is a 2 points, yeah, A and B point. So I'm having a Q amount of charge at point B. I want to transfer this Q amount of charge from point A to B. Then I have to do some work done to transfer Q amount of charge from B to A. Q amount of charge from B to A. That is what we used to call it as a potential difference. PD, or we can say voltage. Am I right, everyone? Yes, please.
Yes,
Yeah. So the same thing here, again, same. So instead of charge, this is electricity, so we are talking about the charge. Now, gravitation means we'll speak about what, guys? Mass. So that's all it is there. So there is no difference even. It is exactly similar. So what is the gravitational potential? That's what gravitational potential or potential difference in the gravitation. So let us take it, everybody. So gravitational potential. So potential difference. Okay. So potential difference means, let me take this is a point A and this is at point B. Are you clear, everybody? So 2 points I have taken. One is point A, another one is what? Point B. Now I'm having some m amount of mass at point B. Very, very small mass. So, but here what we have taken electricity, Q amount of charge. Am I right or wrong, everyone? So here we are taking m amount of mass. Now, keep it in mind, but there is a condition also here. So I want to transfer this mass like that. I want to bring it to the point A. So definitely I need to do some work done. Will you all agree with me, everybody? Yes, please. All of you. So that is what the potential difference. So potential difference, this is VA, potential difference at BV. So this is the initial potential difference. This is the final potential difference. So potential difference is equals to VA minus VB is equals to. So I am bringing some amount of mass M from which point to which point, everybody? Yes, please. Amount of work done to transfer the mass from B to A. What? For what purpose? Work done? For transferring mass. So this is only we used to call it as potential difference. So remember, here the most important thing, we have to bring that mass M with no change in kinetic energy. That is very, very important. So finally, the change in kinetic energy must be equals to what? Yes, Pradosh? No change in kinetic energy means change in kinetic energy is zero, means in the sense of what? Delta. Change in kinetic energy must be equals to, everybody respond, zero. That is what we used to call it as a potential difference between point to point B and point A. Any doubt? Anybody can ask. Clear, everybody? Do you understand, Amma? Please respond. So now, if I ask you potential difference, potential at a point. So now, for example, all of you observe very carefully. Any doubt you can ask me. So let me take the point is A. I want to find the potential difference at this point. So only single point I have given you. So by the time no another point is there. Here means 2 points is there. One is B and A. Here no known point. So always if they will ask you calculate the potential difference at a point, you should take it as a reference point as a infinity. What is your reference point, everybody? Love you? Infinity. And potential difference at infinity is always equals to what, everybody? Speak, guys. 0. Do you understand, Pradosh, Rudreswa? That is what. So, I am having a point. Let me take the point that is what B point, which is actually at infinity. B means infinity. Having a mass M. Now I want to bring this mass M from point infinity to point A with changing kinetic energy or without changing kinetic energy. Everybody, without changing kinetic energy. Do you understand, Ra? Speak, guys. Without changing kinetic energy. So, VA final and this is initial. So, VA minus, what is the initial? Initial, that is what? V infinity. B means infinity only. So, which is equals to work done to carry mass M from infinity to point A divided by mass M. So now you can see, as I said, potential difference at infinity, which is equals to what, everybody? 0. So the potential difference at a given point, any point, this point or whatever the point, potential difference at a given point is equals to work done to, that is what, mass, work done per mass carrying from infinity to point A. Infinity to point A. That is what is the potential difference of a given point. That is what you have to remember. I hope you all are clear, everybody. Yes.
Yes,
And what is
sir.
the unit of work done? Unit of work done is joule and unit of mass is kilogram. So this is the gravitational potential difference. Joule per kg. Joule per kg. But if you are transferring the mass from B point to A point or from A point to B point, keep it in mind, everybody. If it is B to A, it has to be taken, whatever that is, I will say. Understanding? It has been reversed, negative. A to B, it has been taken as a positive. Where it is, I will say that. So now one more thing you have to remember. When it is transferred from B to A or A to B, something should not change. That's what I said you. What should not change, everybody? Yes,
Kinetic.
kinetic energy. That is, so change in kinetic energy, delta K must be 0. Means velocity change mudiyadu. So it has to be very, very slow. Ellame understand, Amma? Clear, everybody? Please respond.
Yes, sir.
What you have to do it. Make it quick. Anything doubt, you can ask me till here. So this is what is potential difference of a point without, I am taking a reference as a what? Infinity. So that V infinity is equals to 0. So by applying that, I got the VA, potential difference of at a point, given point A is equals to work done from, work done to transfer the mass per unit mass from infinity to point A. So that is what is the potential difference. But before electricity, class 9th, class 10th, what used to study, everybody? Do you remember, everyone? Work done to transfer Q amount of charge. That is what we used to call it as a potential difference. Am I right or wrong? Yes, please respond. So class 10th, what is that? Voltage is equals to amount of work done to transfer the Q amount of charge. That is what is called it as a PD, potential difference. But here gravitational potential difference. So I hope you all understand. Anything doubt, you can ask me. Please kindly don't join lately. It will always will impact. Okay. So this is what it is. Anything doubt, you can ask me till here or else you proceed. So this is what is the gravitational potential difference between any 2 points. So this is what point A to B, B to A. So now, what is the gravitational potential due to mass m? Means at a given point, if there is some mass, then what is this gravitational potential energy, whatever it is? Okay, so that is what. In this, anything doubt, anybody can ask me, or else we'll proceed further. Are you clear, guys? Yes, please. Call to Kadiri, Narayan, Princy. Okay, exams, Mane and Samya. Where are absent? Anjivir, Mane and Samya. Yes. Clear, everybody? Do you understand, Amma? Clear? Yes, Radheswar, clear? Next, we are saying gravitational potential energy. Gravitational potential. Okay, everybody? Due to mass m. So please try to listen this one. So this is the most important one which you need to understand. So let me take all of you. There is a mass m at infinity distance, and I know the point P, that is a point P. So if I want to transfer this mass from infinity to point P, so definitely I need to do some work. Am I right, everybody? Will you all agree with me, everyone? Yes, please. So potential difference at this point is equals to, can you tell me what exactly happens, everybody? What is the formula? Transforming, that is what? Work done to transfer from infinity to P point divided by mass m. So now you can see. So if you notice it, so all of you observe very carefully. So this is the formula. Vp is equals to omega, that is what? Sorry, work done to carry the mass m from infinity to, yes please, particular point. So this is what is potential difference of that point. Now, that is not is our heading. What is our heading, everybody? Check it, all of you. Gravitational potential energy due to mass m. So there is an external mass near to that. So for example, if this is the point P, all of you observe, and this is the point mass m, so at the infinity. So we all knows that always this one is trying to attract. Always it is trying to attract it. But there is someone who will always exert outside. That is what we used to call it as. What we used to say? F, please respond. F external. Am I right or wrong? If this force is acting like this, then there is opposite force also. According to, you can see, if this body started moving from infinity to point P, so we all knows that a body which is in state of rest remains in state of rest. The body which is in state of motion remains in state of motion. So what is that, everybody? Anybody remember that? What is that called it as? A body which is in state of rest remains in state of rest. Understanding? A body which is in state of motion remains continuous in state of motion. So this is actually, you can see, there is a law regarding this. Unless they are experienced by a compel external force, so they will be always like
Law.
that. Yes. What is that, everyone? Newton's first law.
Law.
Everybody? So according to Newton's first law, if this body is trying to move, that is what? Unless and until a body can compelled by an external force, so a body which is in state of rest remains in state of rest. A body which is in motion remains in state of motion. That is what is the formula. So now, according to Newton's first law, all of you observe very carefully. So the force which is required, which is attracting this mass m to the point P, if it is acting between them, then definitely there is an opposite force always. That is what? F external force. Because why F external? I'll teach you. Because we have studied that something should not change. What is that, everybody? All of you. Change in kinetic energy should not change. So that is a reason. Always we have to go at what, everybody? Understanding, everyone? Slowly, very, very slowly it has to be. Clear? So means there is no change in velocity. So there is no change in kinetic energy. Do you understand, everyone? Please respond, all of you. Clear?
Yes, sir.
Yes. Now, What is our heading? All of you check it. What is our heading in this concept? All of you. What is our today's heading?
Potential
It's
detail.
gravitational potential due to mass m. That is our target. So let me take the point P. All of you observe very carefully. And mass m is present at r distance, because they're asking this only. Am I right or wrong? Reference point is whatever you can take. So potential difference due to this mass m, that is what is the thing. So now, and we know that this mass m is present at infinity. So now you can see if this body is both are attracting like that, then there is an external force which will make it, understanding, which will controls, there is a motion, so that no change in what, everybody? Yes, please. No change in which energy, Ra? Kinetic?
Energy.
Kinetic?
Kinetic.
Understand? That is what. So, if then the point is at B, then it is taking a more time to reach us to the point B. From infinity to that, then you can see all of you. So, VP is equals to, please remember, amount of work done to transfer, understanding? A mass m from infinity to P. Amount of work done to transfer the, understanding, to transfer mass from infinity to P. So there is always a force of external force. That is what we used to say external agent. So the work done to do that one, which we used to call it as a external agent. That is what external force. Otherwise, there is a change in what energy? Kinetic energy, so that it is not big. So when the kinetic energy of a particle remains same, when they are moving very, 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 very slow. That is what you have to remember. So divided by mass m. So this is what is the formula at a point P anywhere. If you want to calculate it, this is what is the formula. Any problem for anybody? You can ask me. Clear, guys? All of you? Yes, that is what. Now, a mass m is at infinity actually. Now, there is a force of attraction. That is what Fg. And there is F external. So, which is what we can say. So, this is what if you make it. So, mass m will be at point P. You can notice with respect to the radius r, then you can see all of you. So what will happen in this case? The formula will come. So Vp is equals to minus Gm divided by R. So this is the formula. I hope you are clear, everyone. So Vp is equals to minus Gm divided by R. So now this Vp is actually a scalar quantity. So what will happen, everybody? No directions and all. So what is the final formula, everyone? What is the final formula? Potential difference is equals to minus Gm divided by R. This is the formula. This is the formula, and it is a scalar quantity. It does not have, understanding, magnet direction. It has only magnitude. That is what you have to remember. Any doubt, guys, in this? You can ask me, or else after you can ask. Any doubt, anybody? You can make it clear, everyone. Yes, Pradosh.
Yes.
Clear, any doubt, you can ask me, or else we'll proceed further. Please make sure it. So Vp potential difference at a point is a scalar quantity. And what is the derivation? Minus Gm by R. So that is the formula. So any doubt, anybody you can ask. Are you clear, everybody? Yes, please.
Yes, sir.
So make it quick. Any doubt, you can ask. Clear, everybody? Shall we proceed now? Next. Yes. Now let us see the derivation. How this derivation comes. That is very important. Okay. Now always you remember, if a body is trying to move towards to that attraction, then always the work done by the external force, which is always what, everybody? Yes, please. Work done by the external force. If I consider this is the positive, yes. If I consider this is the positive and this is the negative. If I consider this is the positive and this will become the what, everybody? It will become the negative. So now, let us see, all of you. So there is a mass M, okay? So, which is actually at a point P. Now see, it is not at infinity. It is at what point, everybody? Yes, please. Point P. So now you can notice it. All of you observe. And this mass M, we have to transfer slowly without changing its kinetic energy to a mass, that is what, a point whose mass is M. That is what it has to be taken. So now, you imagine that, let me take everything. So there is a mass capital M, which is actually, like we can say, that is what the point, due to the capital M, what is the change in G? That is what it is. So that is what is this mass M. So now, this is the mass M, okay? And the distance between them, distance between the point and that, let me take here. So this is a mass and this is the distance between them is R. Then force of attraction between these two, which is equals to G into capital M into small m divided by R square. Now, same way, imagine, if I take this one, for example, this body has been moved. You can see if suppose this body comes here, then you can see this is the force of attraction. This is the what force? Just now we have studied. What is the force it is actually? Please respond. Which is always acting, trying to take the body away. F external. Understand that? So that is what. So this is F external and this is what is the force of attraction. Now, they are asking if this body is at here, this is what is the FG. Now, if this body will reach us to this point, then what is the work done to carry the infinity to that particular point? That is the question. So I will say you, it is acting actually, see that displacement of the body in this direction, but applied force is this direction. So work done is positive or negative? Everybody? Work done is a positive or negative? Please respond. Because it is acting towards to this and this body is actually acting towards to this. So without changing kinetic energy, they have to be carried. So that is why. So let it, you can take it, everybody. So work done to transfer charge from infinity to particular point P. So you should consider always, what is that, everybody? Please respond. So let us verify the formula. What is the formula? We got it. Change in kinetic energy is 0. So derivation minus Gm divided by R. So let us start now. First, let me take between A, that's what, M, and here itself is the R. So that is what, distance between them is R. So what you have to do it? Clear, everybody? And you tell me one more thing also, I'm asking you. Do you think here R, for example, here till here it has been, let me take R. After certain distance, for example, the body is reached to here. Then from here to here, I will take it as a X. Then can you tell me what is the gravitational force? Fg is equals to, second one, G into capital M divided by, is this R is remains constant or varies? Yes, please. R is remains, varies. Am I right or wrong? Please respond, everybody. That point may come here, the point may come here, the point may come here, the point may come here. So whatever it is. So Fg, understanding? So Fg is equals to Gm into M divided by X square. So why I'm taking one time R and one time X? Is the distance is remains constant? I'm asking you people. Is the distance is remains constant? No. Am I right or wrong?
No, sir.
That is what. So R will varies. So in this case, you can see, so as this R is inversely proportional to F, so that F is not actually, you can see constant. So because it is depending on, that is what, R and all. So the F is actually, if you take it is not constant. So we can say work done is variable force or it is a what force, everybody? It is the variable force only. So work done, understanding everyone? Please respond. Work done to transfer the charge from P to where, everybody? P2, where guys? Let me take, till now everything we have taken from infinity to particular point. But let me take this side P to infinity. So if you can notice it, so what is the limits? Anybody can tell. So P to infinity, which is equals to external, work done by external, always. Variable work done, can you tell me what is the formula? Variable work done formula we have studied in second or third chapter, which is equals to what? F into dx. Am I right or wrong? Speak, guys.
Yes,
That is,
sir.
now we are moving from point P to infinity. So one point is P, longer infinity. So that this is the limits of this one. Now f dx. So now you got it. Well, 1 minute. You got it that, and you tell me what is f? F equals to what? Just now we have got it. G divided by x square into dx. So r square x square, because that is not remains constant. Am I right or wrong? Please respond, everybody. It is not remains constant. Yes or no, guys? So that is what I'm writing in place of f. G into capital M into small m divided by x square into dx. Now, if I take here, you can see. So P at point, what is the P point? Anybody? What is the distance which is equals to R? Am I right or wrong? At the exactly. Yes or no, guys? Please respond. That is what. So I will say P is equals to R. So limits are R to infinity, G into capital M into small m divided by x square into dx. That is what you have to remember. Anybody having any doubt, you can ask me. So GMMW is constant, which is equals to integration from R to infinity dx divided by R square. Ma, girls, also please make attention. Anything doubt, you can ask me. So next, GMM is okay. So now this is dx by x square. Sorry, dx by x square. So can you tell me dx by x square? What is the integration? Dx into x power minus 2. So am I right or wrong? Yes, please respond. X power minus 2 plus 1. What will happen? Divided by minus 2 plus 1. So which is equals to x power minus 1 divided by minus 1. So this is what is actually, if you have taken, what will happen, everybody? If you have taken amount of work done due to the, okay, what is that, everybody? Due to the point, the distance between the point to the infinity, that is what P is equals to R. So that is what you have to remember. So what is the formula, everyone? Still not yet over. So can you tell me what is that? Dx divided by x square will comes minus 1 by infinity, minus 1 by, actually infinity is not, like x, because it is x. Okay. So how it will be means like this it will come. So x power minus 1 divided by minus 1. That's all it is. Okay, wow. Understand? Please respond. So that is
Yes, sir.
what. So now you can substitute the limits from R to infinity. So do it, everybody. G into capital M into small m. I'll substitute infinity minus 1 by infinity minus of minus 1 by R. So this is what? So which is equals to G into capital M into small m. So you can take it 1 by infinity, anything is 0, minus into minus plus, which is equals to R. So now, if you notice it, we got it from point A to infinity. We got positive or negative. Verify it, everybody. We got it positive or negative. Please respond. Yes, please. All of you. So it is positive or negative. Check it. P to A is, yeah, P to A it is going. So it is a positive. Infinity to P, it is a what actually? Infinity to P, it is actually what? Negative. So we want what, brothers? We need point P to infinity or infinity to P. Basically, check it actually. P to infinity. Am I right or wrong? So means a charge is at infinity. We need to do the work done to bring from infinity to the particular mass. So then, what is the formula? Anybody can tell? Everybody, speak loudly, guys. So we got it finally. G into capital M into small m. Okay. So G into capital M into small m into 1 by R, which is equals to G into capital M into small m divided by R. Where amount of work done to transfer from infinity to where? Everybody. Infinity to, please respond. Point P. So that is what is the formula. But this is from point P to point infinity. But we are solving from where to where? Infinity to, please respond. Infinity to point A. So keep it in mind, always G value is a conservative force, and always work done by them, which is equals to 0. So that is what you have to remember it. Now, we will get the VP formula. What is the VP formula? Anybody can tell? Check your notebooks and tell me. What is the derivation we got it? VP is equals to. Just now I have taught you. What is the VP equals to formula? Where are you? Where I have written? I have written somewhere. What is the VP equals to formula, Pradosh? Where I have written? I have not written. Potential difference formula. What is the formula? Potential difference. Work done from, that is what?
Infinite.
Transferring amount of mass from understanding. So amount of work done to transfer the mass from in B to infinity. So that is what it is. So from that we got VP. What is the VP equals to formula? Anybody tell me? What we got it? VP is equals to minus into GM divided by R. Do you remember everyone? Yes,
Yes,
please.
sir.
That is what? A point P. So where a mass M is located, so distance between them is R. Then potential difference is equals to minus GM divided by R. So Y means it is actually coming from infinity. So as it is opposite, I have been taken as a negative. That is what you have to remember. Now, if I get it, so work done from infinity to point P, which is equals to minus Gm into small m divided by R. So that is the formula for calculating work done from infinity to pole. Now this formula will modify it, you can see. So we all knows that this is the work done, and what is the VP equals to formula? Can you tell me VP is equals to what? Work done from infinity to, yes please, infinity to which point? P point. Infinity to P point divided by mass. So what is the work infinity to P point? Just now here it I written G into capital M into small m divided by R divided by mass M. So mm will get cancelled. So what is the formula? Minus Gm divided by R. So this is what is the formula. So here minus indicating that, what is that everybody? Minus indicating plus minus indicating it is what actually? Opposite direction. So that is what you have to remember. Anything doubt in this, you can ask me. So what is the potential difference formula finally? Everybody? Please respond. What is the potential difference formula? Potential difference VP
Minus GM by R.
minus Gm by R. That is the formula. Okay. Now, and one more thing remember. So point mass, capital M, which you have taken, always you need to consider as it is a extremely point mass, because we all knows that potential difference. Yes, please. It is a scalar quantity or vector quantity. Everybody, it is the, yes, please. It is a what actually? Scalar quantity. And mass does not depend on anything. So you remember, capital M is always, remember, you have to consider as a point mass. Because if you have taken a more bigger masses like a rod, cone and all, then infinity number of points is there. So that we have to be very careful. Clear everyone? Yes, please. So always you have to take it as a what? Please respond. Always you have to consider as a what? Point mass. Capital M means what? Point mass. We should not take as a big objects. We should always consider as a point mass. Are you clear, everyone? Anything doubt? Please let me know. Okay, guys. All of you. Yes. Please respond. That is what. So now, so let us see. We can take a HC Verma question. So we all knows that there is a equilateral triangle where three masses are located at equal distance, A, and A. Now question is, what is the potential difference at this point? That is the question. So let me see who will solve first. So minus Gm by root 3A. Option B, minus Gm root 3 by A. Option C, minus Gm 3 root 3 by A. And option D, minus Gm divided by 3 root 3A. So these are the four options. So let me teach myself. So it is equilateral triangle. Equilateral triangle means all the sides are what? Rudreswar? Yes, please respond. It is same, which is equals to 60 degrees, 60 degrees, and 60 degrees. You all agree with me? Please respond, guys. Everybody? Clear?
Yes, sir.
Yes. Now, so they are asking us to find what is the potential difference at the point P. So let me take the same triangle again. I will explain, you observe and later you do it. Brothers, do you all able to understand, brothers? Rudreswa, Mr. Rishi, that is what. Now, this is the point which they are asking. So 3 points are there, all masses are equal, m, and only. So let me find, at one point I will find it, then I will make it 3 times multiply, it is what it is. Am I right, everybody? Please respond, guys, all of you. Yes, brothers, that is what. If it is equilateral triangle, here it is the 60-degree angle. If I'm making exactly towards the diagonal, then what is this angle? Anybody can tell? Yes, please. Respond. What is that angle? All of you. 30 degrees. Yes or no? Respond, all of you. And let me take the point, the distance between them, this mass and the point P is R. Now you can see, all of you, if the total distance is A means, then perpendicularly exactly middle. What is this distance will become? Yes, please. You all should speak. A by 2. Clear? Respond, that is what. Now 30 degrees means, then what will happen? Force 2. This will become what? All of you. This will become what? This is cos 30 and this will become what, everybody? Sin 30. So we have to take it only along this one. So that cos 30. So now cos 30. So cos 30 is equals to, so let me observe very carefully. So what is the cos formula? Anybody can tell? Cos formula. What is the cos formula? Base divided by hypotenuse. So base is equals to A by 2. Hypotenuse is R, which is equals to A by 2R. Are you clear, everybody? Any doubt, you can ask me. Now, from that, we want this R. We don't know. So R is equals to what? Everybody? R will come this side. So it will turn up into A divided by 2 cos 30. So what is the cos 30 value? What is the cos 30 value? Everybody? Cos 30 value, how much, Ra? Root 3 by 2. Am I right or wrong? So 2 will get cancelled. So R is equals to how much, guys?